The mechanism for the reduction of a ketone or aldehyde by sodium borohydride. Essentially, what's happening in this reaction is we're adding two hydrogens to a carbonyl to give an alcohol. The two hydrogens that we add are an H to the oxygen and an H to the carbon. These two hydrogens have very different properties because a carbonyl exists as a resonance structure, like so. The hydrogen that's added to the carbon is a hydride or hydridic. It's negatively charged, and the hydrogen that's added to the oxygen is a proton or positively charged. Okay. The way the mechanism works is the sodium borohydride is the source of the hydride, and ethanol is the source of the proton. And sodium borohydride is not a particularly strong base, and so it can be used in the presence of a proton source at the same time. So, the way the reaction works is here we have sodium borohydride. We have the hydride adding to the carbonyl, the electrons going up onto the oxygen. The arrow starts between the boron and the hydrogen because that's where the electrons come from. It's an irreversible process. No minus. Now, we have here, so we have a case of an O minus, a base, with a BH3, which is a Lewis acid. And in this process, you have the acid, the base reacting with the acid, to give us this complex, which is a reversible process. And as a result, we generate another hydride species that can add to a carbonyl. And then again, we have a Lewis base, Lewis acid situation, and that can add to that reversibly. We generate another hydride species, which goes and finds another carbonyl. And then this goes and finds yet another carbonyl. really show the arrow going to the carbon, the carbonyl. Make sure I have all my carbon straight. Which then adds to the boron for the last time. Gives us this. And essentially what happens next is this sits around and it eventually reacts. The key is this step right here being reversible, where this comes on, comes off, comes on, comes off, to give us essentially it's a reversible process right here. Make some space. The oxygen is coming on and off that boron. Like so. Like that. And then what can happen here is eventually this finds the ethanol solvent, and that can deprotonate that. And you get your product plus the ethoxide. Then the ethoxide then enters in this equilibrium, like so, and another one of these falls off. This O minus. Like so. And then this repeats itself. And eventually you end up with this plus your product. Now, that's an awfully long mechanism. There is a shorter mechanism that you're more than welcome to use on exams. The important part is it keeps track of the key events. Mainly, the first event is the borohydride adds a hydride to the carbonyl. Electrons go up to the oxygen. Then, this O- can then simply deprotonate ethanol to give the target product. This is the shorthand mechanism, and you can definitely use it. The thing about sodium borohydride is you have to always remember that there's two types of hydrogens being employed. And where this comes in useful is in the case of adding deuteriums, which are specially labeled hydrogens. They're hydrogens with neutrons, so you can distinguish them. But they behave and react just like hydrogen. And so what you can do in this case is you can add the deuterium to this carbon here. If you wanted a hydrogen on this carbon and a deuterium on the oxygen, then you just need to make your hydride source, sodium borohydride, and your deuterium source, ETOD. And then in that case, your deuterium goes onto the oxygen. What goes onto the carbon is a hydrogen.